Hello everyone, myself Hans. Today we are going to solve the important problem of Jacobians. Here in the question, if x is equal to cos u and y is equal to cos v sin u and z is equal to cos w sin v into sin u, then so that del of x comma y comma z is upon del of u comma v comma w is equal to minus of sin q u and sin square v and sin square w. Let's solve the problem. Given x is equal to cos u and y is equal to cos v sin u and z is equal to cos w into sin v into sin u, then we have to find the value of del of x comma y comma z upon del of u comma v comma w. It is del of x comma y comma z upon del of u comma v comma w is given by del x upon del u and del y upon del u and del z upon del u, del x upon del v and del y upon del v and del z upon del v and del x upon del w, del y upon del w and del z upon del w. We have to find the value and put in the determinant, but we have to know the following, that is, if u is equal to f of x1 and v, once again, and u1 is equal to and u2 is equal to f of x1 into x2 and further dot un is equal to f of xn, then we have to given by the determinant, that is del of u1 u2 into un upon of del of x1 x2 into x3 is given by del u upon del x1 into del u2 upon del x2 and into del un into del x3. This is del un, this is del un, del xn, sorry. Further from this, the value of del u1 upon del x1 and del u2 plus del x2 and del un upon del x2, this is the product of principal diagonal element of diagonal elements of matrix, that determines matrix. From here, if x is equal to cos u, like a form, and y is equal to cos v sin u and z is equal to cos w sin v and sin u, we must remember the following identities. If u1 is equal to fx1 and u2 is equal to fx1 x2 and un is equal to f of n xn plus 1 is given, then we have to you have to find the Jacobians with the multiplication of principal diagonal element. Then from here, that is del of x comma y comma z and del of u comma v comma w is given by this matrix, and from here we can also write, that is del of x comma y comma z upon del of u comma v comma w, and according to the question we have to product Jacobians is equal to the product of the principal diagonal elements of the matrix. This is the principal diagonal elements, del x upon del u, del x upon del u into of del y upon del v, del y, sorry, this is del y, and del z upon del w. Further we have to find the value of del x upon del u and del y upon del v and del z upon del w. Then we have to put, first we have to find del x upon del u, and the del x upon del u is the value of x differentiating partially with respect to u, differentiating cos u with respect to u, that is minus of sin u, and we have to further find, that is del y upon del v, the value of v, one second, the value of y partially differentiating with respect to v, taking the sin u as a constant, that is sin u as a constant, and differentiating cos v with respect to v, that is minus of sin v, minus of sin v. Further we have to find del z upon del w, del z upon del w, and the value of z partially differentiating with respect to w, taking sin v and sin u as a constant, that is sin v and sin u, and differentiating cos w with respect to w, that is minus of sin w, taking minus is back, that is minus of sin w. We have to put the value in the above, that is del x upon del u is minus of sin u, and del y upon del v is minus of sin u into sin v, and del z upon del w is given by minus of sin v and into sin u into sin w. We have to multiply del of x comma y comma z upon del of u comma v comma w, and we have to multiply here, that is here minus minus into minus is plus, and again is minus, that's why we have to put minus is first, and sin u and sin u, sin square u, and this is also, this is sin cube u, sin cube u, and sin v into sin v, that is sin square v, and from here that is sin w. This is equal to del of x comma y comma z upon del of u comma v comma. We have to prove that del of x comma y comma z upon del of u comma v comma w is equal to minus of sin cube u into sin square v into sin w. In the given problem, we must remember the following identities when given u1 is equal to fx1 and u2 is equal to fx1 x2 and dot dot un is equal to fxn plus n plus 1. Then we have to, the value of Jacobians is the product of principal diagonal elements. Here we have to find all the del x upon del u, del y upon del u, too lengthy. That's why we have to learn the identity, and simply we have to multiply the product of the principal diagonal element. We get the required solution. Thank you class, and thank you for watching.